Hey everyone, welcome. Today we're diving deep into what really makes the modern web of data tick. We're going to see how incredibly powerful tools, like knowledge graphs, are actually built from the ground up, starting with their most fundamental single component. So let's jump right in.
So you've probably heard terms thrown around like the semantic web or knowledge graphs. And look, they can sound super complicated, right? But the truth is, these massive, powerful tools are all built from just a few really simple and elegant ideas. So that's what we're going to do here. We're going to build this thing from the ground up, piece by piece.
Okay, so let's get a formal definition on the table. At their heart, knowledge graphs are exactly this: networks. But they're special. They're designed specifically for machines to read and, more importantly, to understand. They're all about making these really rich connections between different bits of info. You know, kind of like how our own brains work.
Yeah, that leads us right to the big question, doesn't it? If a knowledge graph is this huge, sprawling web of information, what's the one tiny thread it's made of? What's its most basic building block? Its atom, if you will. To figure that out, we have to look at our very first piece of the puzzle.
All right, so first things first. Before you can even start talking about something, you need a way to point at it and be sure everyone knows you mean that one specific thing. And on a global web of data, that means you need a naming system that works for everyone, everywhere.
And the answer to that problem is something called the Internationalized Resource Identifier, or IRI for short. The best way to think about it is like a social security number, but for anything on the internet. A person, a place, an abstract idea. It makes sure that when I say Paris and you say Paris, our computers know we're both talking about the same city in France. You've definitely seen its older cousin, the URI. That's the HTTP address in your web browser. The IRI is just the modern version of that, but it can handle characters from any language, which is a huge deal for a truly global web.
And here's the really cool part. IRS can point to, well, anything. Sure, you've got the obvious stuff like a web page, like this one for Ryan Gosling. But it can also be a specific file on some server, or a book using its official ID, or get this, even a person in a university database. The key takeaway here is that it's a permanent name for the thing itself, not just where you happen to find it online.
Okay, cool. So we can give everything a unique name. We've got our list of nouns. But how do we actually say something about them? How do we connect them in a way a computer can get? And that, my friends, is where RDF, the Resource Description Framework, enters the picture. Now, this is super important, so lean in. RDF is not a file format like a JPEG or a text file. It's more like a blueprint. It's a set of rules, a data model, for how to describe stuff as a network of connections, as a graph.
And the wild thing is, the core rule of this whole system is just incredibly simple. Every single fact, no matter how complicated it seems, gets broken down into a basic three-part statement. Seriously. The best way to get it is to just think of a really simple sentence. Subject, verb, object.
So let's walk through it. First, you've got your subject. That's the who or what of the sentence. Then, the predicate. This is the property, the relationship. Basically, it's the verb. And finally, the object. That's the value, the thing the subject is or has or is connected to.
And this three-part structure? It has a name. It's called a triple. And that is the atom we were searching for earlier. This is it, the single fundamental building block of a knowledge graph.
Okay, let's look at a real-world example so this isn't so abstract. Our subject is a person, identified by that unique IRI. The predicate describes the relationship, author in authorship. And the object is another thing, in this case an authorship event, which also has its own IRI. Put it all together, and the computer reads a simple fact. This person is an author in this event. Super simple, super clear, and a machine can understand it perfectly.
All right, so we have names for things, and we can make these tiny little sentences, these triples, but a single sentence is just a factoid, right? The real magic, the third big piece of the puzzle, is what happens when these sentences start linking up.
Think about it for a second. That authorship event that was the object in our last triple, well, there's nothing stopping it from becoming the subject of a brand new triple. So we could have another triple that says, this authorship event is documented in this specific paper. And boom, we've just created a chain. When you do this millions of times, you no longer have a simple list of facts. You have a graph, a web, a true network of knowledge.
And this slide right here is a perfect illustration of how this all works in the real world. On the left, you've got what we see, right? A nice, clean web page for Ryan Gosling on DBpedia. But on the right, that's what the machine sees. It's the raw data behind the scenes, just a bunch of triples.
Ryan Gosling is an actor. Ryan Gosling is a producer. Ryan Gosling is a person. It's this structured data that actually powers the web page we see.
Okay, so this idea of a graph made of triples is awesome, but it's still just a concept, an abstract model. How do we actually, write it down on a file so we can save it or send it to someone else?
Well, that process has a name. It's called serialization, and it's all about turning that abstract graph idea into actual text that a computer can store and share.
One of the first formats for this was RDF/XML. And look, it's super precise, which machines love, but for a human, oh man, just look at it. It's verbose, it's kind of clunky, and it's just really hard for a person to read.
So naturally, people came up with better, more human-friendly ways to write this stuff, and a hugely popular one is called Turtle. And you can see the difference immediately. It represents the exact same information as that messy XML, but it's clean. It's designed to look just like the subject-predicate-object structure we've been talking about, which makes it 1,000 times easier for us humans to work with.
Now, Turtle is definitely a fan favorite, but it's not the only game in town. You've got others, like JSON LD, which is perfect for web developers who are already using JSON, or N-triples and N-quads, which are even simpler and are great for certain tasks. They all have their own little niche.
Okay, so let's boil this all down. What are the key takeaways, the core rules of RDF? First, remember it's a graph model, not a file format. Second, the basic building block is that subject-predicate-object triple. Third, pretty much everything, subjects, predicates, and even some objects, are identified by those unique IRIs. The only exception is that an object can also be a simple value, like some text or a number. And maybe the most powerful rule of all, this data can be spread all over the web in millions of different documents, and it can all be linked together.
And that really brings us to the final, kind of mind-blowing idea here. This simple triple-base structure is so powerful because it's universal. You can use it to describe anything, from complex scientific data to movie credits to your own family tree. So the question to leave you with is, if you could start building this web of data yourself, connecting any piece of knowledge in the world, what would be the first connection you'd make?